Namaste. Welcome to this Papson Distant Learning Program, collaborations with the Janta Television. And today, for class 9, we are taking the subject science for class 9. And in class 9 also, there is 4 category is divided, the whole science book. That is physics, chemistry, biology, and astronomy and geology. Out of that, first lesson of that physics, that measurement we are going to discuss. So for today's topic for the discussion is measurement. That is from class 9. Okay, about the measurement, you might have learned from lower class, like in grade 6, grade 7, grade 8, and in this grade 9 also we are going to discuss the measurement and why this measurement we are continuously reading up to grade 9 is especially the physics. It deals with the measurement of the length, measurement of the mass, and different measurement calculations deal by the physics. That's why this measurement, it is very essential one. And this measurement, it is essential in the day-to-day life also. Whenever you visit the shop for buying the something, then the measurement is essential there, right? And similarly, whenever we perform some scientific work, the measurement is essential one. So everywhere, so if you go to the tailor to sew the clothes, in that case also the measurement is required one. That's why measurement, it is everywhere equally essential one. That's why we are going to learn this measurement. Okay, so let's dive into the measurement chapter of grade 9. So in grade 9, especially we will discuss about the fundamental quantity and the derived quantity. About this fundamental and derived quantity in previously also you might have learned, that we will discuss here. Similarly, fundamental unit and the derived unit also we will discuss on this grade 9. And similarly, we will discuss the differentiation between the fundamental unit and the derived unit and its relation also we will discuss. So a few things about this we have learned in grade 9, grade 8, grade 7, grade 6 also, but a little bit more about that we will discuss on this grade 9. Okay, so let's start this measurement. So before starting this measurement, I have this duster is here, right? So if I ask what is the length of this duster, then for expressing the length of this duster, we need to know some measuring tools. We can use scale also, right? And we can use meter rod also. We can use measuring tape also. So I have brought here one scale for the measuring the length of this duster. So let's see. So if I say check here from here, then it is about 14.5 centimeter. That is the measurement what I have done. This is the non-standard quantity and this one is the unknown quantity. I don't know the length of this duster till now because here is I haven't compared this. That means the measurement is the comparison of unknown quantity with the non-standard quantity. So let's define this measurement. I have said measurement, it is the comparison of unknown quantity with the non-standard quantity. That is the measurement. Now this measurement I have said, so I have asked what is the length of this, right? Similarly, I can ask what is the mass of this object, right? Similarly, if some moving object are there, then I can ask what is the velocity of that moving object, or I can ask what is the speed of that object. I can ask what is the acceleration of that object. That means whatever component we can measure, those component or those quantities are called the physical quantity. So what I have defined, so I have defined the physical quantity. So what is physical quantity? I have already said the quantity which can be measured directly or indirectly, that quantities are called the physical quantity. For example, length I can measure directly by using the scale, so that is the physical quantity, right? Similarly, mass also we can measure That is also the physical quantity. Speed also we can measure. Acceleration also we can measure, isn't it? Height also we can measure. That's why these all the quantities which can be measured is called the physical quantity, right? But some of the quantity, for example, if you are angry, then if I ask the question, what is your level of angriness? How much you get angered? If I ask, then you may think that you have asked the silly question to me, right? You may think I'm a foolish if I ask that kind of question, which cannot be measured one. You may love your parents, father, mother. If I ask how much you love to your parents, then that may be the silly question, isn't it, right? So those quantity which cannot be measured, that is not physical quantity. Example, love, and similarly happiness and anger. So these cannot be measured ones, so they are not considered as a physical quantity. And this physical quantity, we can express this physical quantity in terms of two parts. One is the, so physical quantity we can express in terms of, one is the number and unit. For example, if I ask the mass, then if I ask the mass of my body, then I may say 50 kg, right? So this I have expressed of mass. So mass is the physical quantity, and this physical quantity I have explained in terms of number, right? This is also called the quantity also, and also the unit. So physical quantity can be explained in terms of number and the unit. So this is the representations of physical quantity. Now, if we check the different kind of physical quantity, then there is a two kind of physical quantity we can see. Okay, the types of physical quantity. So types of physical quantity, we can divide this physical quantity into the two types. One is called the fundamental quantity, and next one is called the derived quantity. So the quantity which is not depend upon the other quantity, that is called the fundamental quantity. For example, length. Can you explain the length in terms of mass? We cannot, right? Similarly, length cannot be explained in terms of volume also, isn't it? That's why the length is independent one and it doesn't depend upon the others, so it is called the fundamental quantity. Similarly, mass also fundamental quantity, right? Temperature also fundamental quantity, and the electric current also fundamental quantity. So the fundamental quantity that is not depend upon the other quantity, they are called the fundamental quantity. And similarly, the derived quantity mean which can be expressed in terms of fundamental quantity, that is called the derived quantity. For example, if I say the speed, then this speed can be explained in terms of distance, that is length, right, and the time. So speed can be explained in terms of distance and the time, so it is the derived quantity. Similarly, if I say the acceleration, I can represent this by A, and this acceleration also the derived quantity. Why? Because it can be explained in terms of velocity and the time. So acceleration, it can be explained in terms of velocity and the time, so this acceleration also the derived quantity. So this is about the fundamental quantity and the derived quantity. Now, one question is for you, why the velocity is called the derived quantity? So you just give the answer, whatever we have discussed previously. So you can answer this, I think, right? So another one we have is unit, right? So what is unit? Let's see. So if I want to measure the length of this line, let's say this length of this line, then this may be, let's say, 18 centimeter, right? Here 18 is there and the centimeter is there. This centimeter is the unit because it is the standard quantity, with which we can express the unknown quantity. That's why it is called the unit. So the unit, it is the standard quantity which are used for comparing the unknown physical quantity. And especially this unit, it can measure the similar kind of quantity. For example, this centimeter, we can use that for measuring the length, right? To compare the length, height, distance, for comparing that, we can use the centimeter, meter. That means the similar quantities can be measured by using the unit. So example of the unit, I have said this centimeter, it is the unit of length. Meter also, that is a unit of length. Joule is there, that is a unit of work or energy, right? Similarly, the force is there, that is the Newton. The unit of force is Newton, that is also the unit. Okay, so this unit also can be categorized into two groups. Depending upon its nature, there is two type of units are there. So unit also divide into two groups. They are fundamental unit, and the second one is derived unit. So simple definition of this fundamental unit is the unit which are used to express the fundamental quantity is called the fundamental unit. Also we can say it, the unit which are independent on other unit, they are called the fundamental unit. Example is like meter, that is fundamental unit, right? Similarly, kilometer also the fundamental unit, and similarly the kg, kilogram, that is also the fundamental unit. Second, that is a fundamental unit. Ampere, that is the fundamental unit, right? So similarly, 7 type of fundamental unit we need to discuss. You can see in the screen also, there is given the 7 fundamental unit. So you can see here also, right? Length is there, time is there, mass is there, electric current, that is ampere, that is also the fundamental unit. Similarly, amount of substance, that is also the fundamental, the mole is the fundamental unit. Temperature and the luminous intensity. These are the example of the fundamental unit. So we can use meter scale for measuring the length, right? Similarly, we can use the thermometer, digital thermometer you might have seen whenever you suffer from fever, then your parents or doctor, they used to measure. So that digital thermometer and the thermometer, they can be used for measuring the temperature. Similarly, pan balance, bin balance are there, that can be used for measuring the weight. And similarly, clock, that can be used for measuring the time, right? And there is one more device you have seen on the lowermost right corner, which is called the photometer, which are used for measuring the intensity, that is luminous intensity is measured by this device, which is called the photometer. And you can see on the top right corner, there is a ammeter is there, which are used for measuring the amount of current. You can see electricity in your home, and the amount of current flow through it can be measured by using the device called the ammeter. Now next one is derived unit are there. So derived unit are the unit which are used to express the derived quantity. Derived quantity you have learned previously also, like velocity, acceleration, force, right? Weight. They are the example of derived quantity, and the unit of those derived quantities are called the derived unit. So let me give the one example. So if there is force, it is the derived quantity, and the unit of this force is called the derived unit. So unit of this one is Newton, right? So it is the unit, derived unit. Similarly, if there is velocity is there, velocity, that is meter per second, it is also the derived unit, right? Similarly, if I say the acceleration, the unit of acceleration is meter per second square. This also the derived unit. Another definition also there for this derived unit, the units which can be expressed in terms of fundamental unit, they are called the derived unit. For example, this Newton, so let me derive, and why it is called the derived unit, let me show. So force, we can use the formula for measuring the force is mass into acceleration. This is the formula. that force equals to mass into acceleration. Now, what is the unit of mass? It's a kg, and acceleration is meter per second square, right? So kg, it is a unit of mass. Meter per second square is the unit for the acceleration. So this combinedly called the Newton, and this Newton can be explained in terms of kg, that is the unit of mass, meter, unit of length, second, unit of time. So this Newton is called the derived unit. Why it is called derived unit? Newton can be explained in terms of kg, that is a unit of mass, meter, that is a unit of length, and the second, that is the unit of time. That's why Newton is called the derived unit. Clear? So similarly, if we want to explain, let's say velocity, why the unit of velocity is called the derived unit, let's say. So velocity formula is displacement by time taken. So velocity is displacement by time taken. Displacement, it is a length, so unit is meter, and time, it is a second, right? So unit of velocity is meter per second, and why it is called the derived unit is it can be explained in terms of meter, that is the unit of length, and the second, that is the unit of time. That's why the unit of velocity also called the derived unit. So you can see in the slide there is a different derived quantities are given over there, and their formulas also given over there. You can see in the right hand side also there, right? And their derived unit and the basic unit involved on that is explained over there. So let's see the acceleration. One acceleration, let's see why the unit of acceleration is called derived unit. Let's see. So acceleration is there. Acceleration formula is velocity by time taken. This is the formula for acceleration, and velocity is meter per second. This is the unit for the velocity, and time taken is second. So you can see 3 layers here. So let me write this in the proper way. That is meter per second, and the second is that this is main divider one, so 3 layer it forms over there. So let's change that into the 2 layer. So we can write down here divide 1. So this is meter per second into this denominator will be reversed one whenever we change that into the 2 layer. That is 1 by s. That is meter per second square. So this is the unit for the acceleration, and our questions is why this unit is called the derived unit. So let me explain. The unit of this acceleration, that is meter per second square, can be explained in terms of meter, that is the unit of length, and the second, that is the unit of time. So the unit of this acceleration, it is called the derived unit. Clear? Now next one is one more, let's see power. So one more we have is power, and power formula is power equals to work done by time taken. This is the formula for the power, right? And unit of power, we will write down this W. That is the unit of power, this power, right? So work done, and work done we can calculate by the force into displacement, and the time is second, right? Now what is the force? Force is, again we have previously mentioned, this mass into acceleration into displacement by time. So let's write down the unit of these. Mass is kg, and acceleration is meter per second square. It's a meter per second square, and this distance is meter divided by s. So if we write down, let's write down this like this. Okay, let me write down in up. So this one is kg, and meter is there, that is meter square, right? Meter square, and time is there. So second square is there in the denominator. Similarly here second is there, that is second cube is the unit, which is commonly called as the watt, right? Now why this watt is called the derived unit is, the watt, it can be expressed in terms of kg, unit of mass, in terms of meter, unit of length, in terms of second, unit of time. So the watt is called the derived unit. Okay, so some other example also I have shown in the slide, right? Now there's some questions are there. Why the kilogram, kg, is called the fundamental unit? That you have got the idea that I have already explained, right? Similarly, acceleration, why acceleration is called the derived unit? That also we have explained previously, right? And why the unit of density is called the derived unit? That also we have explained. So let me show about the density. Okay, density. Density symbol is d, also we can write down, and rho also we can write down. So here I will mention this rho. Rho equals to mass by volume. That is the formula for the density, right? Now what is the unit of mass? It's a kg. And what is the unit of this volume? That is meter cube, right? SI unit is meter cube. The formula is L into B into H, and the three quantity, they are distance. That's why it's a meter cube. So density unit is kg per meter cube, and it can be explained in terms of kg, unit of mass, meter, unit of length. So the unit of density is called the derived unit. So these are about the derived unit and the fundamental unit. Now about the SI unit, or why the standard unit are essential in the world, right? You might have heard about the SI unit that are followed by all the countries in the world, and why that SI unit are essential one. So let's discuss about that. Okay, okay, in different countries, if we talk about the Nepal also, we in the village, whenever we visit the village, then if you wants to explain the mass, the people over there, they will explain in terms of mana, right? In terms of muri, in terms of seer, isn't it? These kind of units they are using while they express the mass. Similarly, the people in the village, they explain the length of any material in terms of hat and the bitta. For example, this is the bitta, right? If you visit some places, then they may measure the length of the clothes with the help of this bitta also, right? They may use this hat also. It is called the hat, right? And if the foreign people or other country one people, they visit on the village, then they will not understand this kind of unit. Similarly, other countries also, they may have their own kind of unit in the local places, which cannot be understood by us also and the other people also. So due to these difficulties, the people, they find the same kind of unit which can be standardized all over the world, which is called the SI system of unit, or it is also called the standard unit also. So to make the global trade easy, right, the people, they can easily understand the measurement throughout the world, the standard units are introduced one. And what should be the characteristic of this standard units are, that should not be changed with the place. What I mean is, if we use that unit on Kathmandu, that is the one unit, and if we use that in the Tarai region, then that should not be the another unit. That means it should not change with the place to place. That is the characteristic of the standard unit. Similarly, it should not be affected by the other physical quantities also. If there is temperature is there, if there is pressure is there, that should not affect to that standard unit. And it should be easily reproducible one. What that means is, we can change that into the multiple and the sub-multiple also easily. That is the characteristic of the standard unit. And about this unit, you might have learned 3 type of unit in the lower class, especially 4 types, 3 types, and 1 type is the modified form. We can consider that 4 types also. You might have learned in the lower class. What are they? Like FPS, system of unit. So we are going to discuss about the system of unit. Okay, system of unit, different system of unit we are going to discuss. System of unit. So first one is FPS, system of unit. System of unit. This you might have learned in lower class, right? CGS, system of unit. Third one is MKS, system of unit. And last one, it is the modified form of MKS, which is called the SI, system of unit. So this 4 type of system of unit are used worldwide, right? So let's discuss about this. This you might have learned in grade 8 also. FPS, F stands for the foot, P stands for the pound, and the S stands for the second. Foot, pound, and the second. So the definition of this FPS, system of unit, is the system of unit in which the mass is measured in the pound. Okay, let's start from the length. Length is measured in the foot, mass is measured in the pound, and the time is measured in the second, is called the FPS, system of unit. And specially, it is also called the British system of unit also. This FPS, system of unit, it is called the British system of unit. And next, this CGS, system of unit. So let's follow the same pattern, whatever we have defined previously, when C stands for the centimeter, right, length. Okay, and this G stands for the gram, unit of mass, and the S stands for the unit of the time. So let's define the CGS, system of unit. The system of unit in which length is measured in the centimeter, mass is measured in the gram, and the time is measured in the second is called the CGS, system of unit. And this system of unit is also called the French system of unit also. CGS, system of unit, it is also called the French system of unit, right? So last one is there, second last one is there, MKS, system of unit. So same pattern you can follow for the defining this. This M, it's a meter, K, it's a kilogram, and the S, it is the second, that is time. So let's define the system of unit in which length is measured in meter, mass is measured in kilogram, and the time is measured in second, is called the MKS, system of unit. So once again, the system of unit in which the length is measured in the meter, mass is measured in the kilogram, and time is measured in the second, it is called the MKS, system of unit. It is also called the metric system of unit also. Okay, this MKS, system of unit, it is also called the MKS, system of unit. Now, last one is their SI, system of unit. This SI, system of unit, it is the derived from the French language, right? And in the French language, this one is also called the Système International de Units, right? Which means that international system of unit. I have mentioned in the slide also this one. So that means this, you can see on the right hand side there, this is the Système International de Unit, which meaning is international system of unit. And it is derived, or it is prepared on the 1960 AD with the help of the General Conference of the Weights and Measure that introduced the SI, system of unit. As it is required for the global trade, this system of unit is introduced one. And this SI, system of unit, it is modified form of the MKS, system of unit. That's why it is also called the rationalized MKS, system of unit. this SI system of unit is derived from the MKS system of unit, so it is called the rationalized system of the rationalized MKS system of unit. Okay, so I have listed the different unit that is related with this SI system of unit. So you can check their length, meter, right, mass, kg, time, second, and electric current, ampere, capital A. So this about the how to write this symbol we will discuss a little bit later on, and amount of substance, that mole is there, and temperature, Kelvin is there, and luminous intensity, candela is there, and the two more units, it is considered as a supplementary unit like angle, radian. The symbol for this one is RAD, radian. You might have learned in the geometry also the measurement of angle. For that, radian is the this SI unit or SI system of unit for the measurement of angle. Similarly, solid angle is there. That is the steradian is used one for measuring the solid angle in SI system of unit. So these are the SI system of unit of the different quantities that we use in our daily life. Okay. Now, what is the way of writing the symbols of the unit? Let's check. For example, if I want to write down the length of the, let's say this board, let's say 2 meter. Okay, the length of this board, let's say 2 meter. 2 meter. So either I should write down capital M or small m. That also we should know how to write down this kind of symbol, right? If there is, let's say, derived unit are there. Let's say Newton meter square is there. Let's say that is Newton meter square. Is this correct or not? To know that, there should be the certain rules should be known one for writing this kind of symbol. So let's see. In the physics, some of the unit they are given to honor the scientist for their work. For example, if I say Newton, that is the to honor the Sir Isaac Newton, right? And Joule, that is also, right? And similarly, the Newton also, and the Watt also for honoring the scientist. So that kind of unit, the symbol is represented by the initial capital alphabet. For example, if I say Newton, it's a unit, right? So the symbol is capital N. So remember that the unit which are given for honoring the scientist, their symbol must be represented by the initial capital alphabet of their name. Newton, so I have said Joule also, right? And I have said Watt also. So this symbol must be represented by the capital alphabet, right? Similarly, other symbol, the usual symbol that can be used with the small alphabet. For example, if I write down the meter, then this is the small alphabet, right? Kilogram, kg also a small one, right? Centimeter also small one. So other unit we mention with the help of this small alphabet, right? Similarly, while writing the full name of the unit, if those units are used for expressing, or those units are for honoring the scientist, in that case, that should be mentioned with the small alphabet. For example, if you write down this Newton, then it is the name of the scientist. But for the symbol, for the unit, we will write down this Newton. So while writing the unit, please write down this with the small alphabet while writing the full name, and while writing the symbols, you must have written in the capital alphabet. So this thing we have discussed, and one more thing, if we are writing the compound unit, in that case, we will write down by separating with the space, or either we use the dot between that. For example, if I want to mention this Newton meter, then Newton dot meter, or simply Newton space, and the meter should be used one. So this thing we have discussed today, and about this measurement. Some numerical problems are there that we will discuss on the next classes. So let's practice whatever today we have discussed. And we have discussed today the fundamental unit, derived unit, fundamental quantity, derived quantity, right? And the different system of unit like CGS system of unit, MKS system of unit, FPS system of unit, and the SI system of unit. So this kind of unit today we have discussed, which you have discussed in the previous classes also, like in grade 6, grade 7, and in grade 8 also you might have learned that. We have continued one, and some more things also we have discussed one. And we have also learned that how to write down the symbol of the units in the proper way. That also we have discussed in the today's class one. So remember that whenever you mention the symbol, right, unit for scientist name, right, which are derived from the name of the scientist, while writing the symbol, that must be capital one. For example, this Newton, Joule, and the watt is there. That should be mentioned in the capital letter. And whenever we write the full name, then that should be in the small letter. For example, this Newton. And if you want to write down the watt, then that must be written as a watt, small. So this represents the unit. And if you write down this in capital, then that will be the name of the scientist. So these things we have learned today. And in next class, we will continue. And so let's practice whatever we have discussed for today. And thank you very much for joining the class. Hope you will enjoy the remaining time. Thank you very much, and namaste.